So here's one more example of Charles' law and using the coefficient of thermal expansion to express volumes. We're going to look at this formula here that we examined in another video, where the volume at some temperature of some object, let's just draw another little cube of, let's say, olivine. We'll use olivine for this example again. We've carved it into a cube. It would not naturally grow into that shape. This volume will be a function of whatever the initial volume is plus a correction, and that correction is that initial volume multiplied by the coefficient of thermal expansion multiplied by delta T, some heating or cooling. So in the last video we looked at heating. We allowed the temperature T to increase from 0 degrees centigrade to 1,000 degrees centigrade. So our delta T then was 1,000 degrees C. As you can see, 0 degrees centigrade is a very handy reference since it allows us to make the calculation a little bit simplified. And then we had an initial volume of 10 cubic centimeters. Well, we'll do a similar kind of calculation, except we're going to change the delta T. We're going to do some cooling. So we will erase the chalkboard here and just rewrite the equation. So the volume at some temperature will be V naught plus V naught alpha T, or delta T rather. But the delta T here is going to be a temperature that is below 0. And I think that it might be fun to, let's say, take our hypothetical olivine block, and what we will do is we will cool it, and we'll cool it down to liquid nitrogen temperatures. So we'll put it in a bath of liquid nitrogen, we'll take it out of the freezer, and then we'll have it shrink down to some smaller volume. How small will that volume be? We're going to take a very simplistic look. We're going to assume that alpha doesn't change much with temperature. It probably would over the very large temperature changes that we're looking at. But anyway, let's keep alpha constant, and we'll just take this simple case of 3 times 10 to the minus 5 per degree centigrade. So for liquid nitrogen, that is minus 195.79 degrees centigrade. And we are subtracting that from our handy reference of 0 degrees centigrade. So delta T is simply minus 195.79 degrees C. Notice that here now the temperature is negative. We're going to introduce a negative value for this correction. So if we put this in, the volume at liquid nitrogen temperature minus 195.79 is going to be equal to 10 cc's. That would be our starting value here. So 10 cc is that block. Plus this correction. But this correction will now be negative. That correction is going to be 10 multiplied by 3 times 10 to the minus 5. This is in units of cubic centimeters. This is per degree centigrade, and then multiplied by minus 195.79 degrees centigrade. Running out of room here. So the degrees centigrade will cancel. We'll just be left with the 10 cc's. The cc is the unit, and this will come out to 9.941. So we'll take this initial value here, and because we have this negative sign, overall that correction is going to be negative by just a little bit less than 1/10 of a cc. So the volume of olivine at liquid nitrogen temperature, if we put it in a bath of liquid nitrogen, if it started out at 10 cc's, it would be at about 9.941 cc. That's probably too many significant digits because really this value of alpha is not constant. But for a ballpark look at these kinds of calculations, this is one way you can do it. And over very small temperature ranges, we can certainly look up an alpha value that is going to be relatively constant for a lot of the kinds of calculations that we do.